but I wanted to personally welcome you to our session today. I think it's going to be a lot of fun. We've got a lot of great speakers, so we'll start here in about 30 seconds. But with that said, for those that don't know me, my name is Kevin Welsh. I am an industry marketing manager here at SICK. I've been with the company for about 5 years, and I'm specifically here to cater to the consumer goods industry. So our session today is hopefully going to help all of you learn a little bit more about your industry, and specifically how to make your industry a little bit safer with some of our great SICK products that we're going to be demonstrating today. So, Anders, if you don't mind, could you pop up our presentation really quick? And we will go ahead and get started. So specifically today, we are going to learn how to maximize machine safety. I would love to be the guy that's going to drone on for you for about an hour, but I have a better team here to do that today. Specifically, we have members like Sarah Starziak, Carolyn Reisdeck, Tyler Gleeden, all of which have dozens of years of experience here at SICK. Some actually even have their TUV certification as well. So you are going to be hearing from the best in the industry, best and brightest. I'm a little biased. But with that said, let me go ahead and invite Sarah Starziak up here to get us started. So Sarah, please come on up, and I'm going to pass the baton to you. So,
awesome.
Thanks.
Well, thank you everyone. Thanks for joining us. So as Kevin had mentioned, my name is Sarah Starziak, and I am a market product manager here at SICK. I am responsible for our safety light curtain and safety switch portfolios, but today we'll be just talking about our switches. So what I will be going through today is all the different types of safety switch technology that we at SICK here have to offer. I'll be going over the advantages and limitations of each technology, as well as providing a live demo of our products. So first and foremost, it's important to understand when you would use a safety switch. Safety switches are typically used for protecting movable guards, so determining if a door is open or closed. And within our portfolio, we have a variety of different types of switches, both locking and just contact switches, so they do not have a locking function. Within the portfolio too, we also have solutions that are used for position monitoring and products that can initiate a safe stop function. So these would be our rope pull switches as well as our e-stops. So the first type of switch technology I'll be covering today is our electromechanical safety switches. Within SICK, we have three main categories of electromechanical safety switches. So the first one is switches with a separate actuator. So these are typically used to tell if a door is open or closed. And so when you open a door, typically a machine or a process would stop. Then we have our safety position switches. These are used for end position monitoring. So if you have outbound goods in your distribution facility and you're trying to get pallets of diapers out, so what you would need to do is use this type of switch to determine the position of a roll-up door. Otherwise, we have our safety hinge switches, and these are used for our mounting of swivel guards and hinges. So what makes these switches safe? There's two main components, electromechanical. First and foremost, electrically. These devices contain at least 2 voltage-free contacts, and that's really what the key is when it comes to safety, is dual channel and redundancy. And you'll notice that trend throughout many of our devices because that's what you look for when making things safe. So with these, we typically recommend for electromechanical switches at least 1 normally closed and 1 normally open, or 2 normally closed contacts. And this is because we want a machine to fail safe. So that's where the normally closed contact comes into play. So then mechanically, in order to actuate a switch, you must have a positively driven operation. Now, what does this mean? It means that you have a positive action to either separate the contacts together. And so with that, it means that if an input and output state tends to slip, you would fail safe. So the output would then go low, which means that there wouldn't be an output and you fail in the safe state. Now, the important thing to note about these types of switches is there are some limitations. With these switches, the performance level is indicative of your evaluation unit. So if you're using a safety relay or controller, this is really what determines the performance level. Mechanically, it is a single channel system, so the maximum safety level you can achieve is what we call a performance level C. A higher performance level can be achieved if you take into account fault exclusion. And so really simply, fault exclusion are specific failure modes that are identified by the switch, but it's saying that that failure has such a low probability of occurring that you can exclude that from happening. So for example, with our switches with separate actuators, if you have that actuator get torn off or broken, that could be a mechanical failure. Now that can be avoided through the different types of actuators we offer depending on your actuation direction. So going into a little bit more detail of our electromechanical switches, again, these are our most cost-efficient safety switch technology. And the important benefit that these switches bring to the table is that they do offer a retention force. So this means that if an application or a machine is vibrating, then the door will remain closed. The limitations of these is the fact that they can be easily defeated. So with those metal actuators, you can easily insert another piece of metal, or operators can overcome or defeat these safety devices. So that's also important to take into consideration. So our next type of switch here is our non-contact safety switches. Now, where typically our electromechanical switches lack, our non-contact safety switches really start to fill in the gaps here. We have three main categories: our RFID safety switches, which are used to determine the status of a door, whether it's open or closed, our magnetic safety switches, as well as our inductive safety switches, which are traditionally used for position monitoring. So if you have a turntable and you're loading parts onto the turntable and it turns into a robot cell, it measures that position of that turntable to make sure it's in a safe state. Now, all three of these devices have different functioning principles. With our inductive devices, they actually have a coil within the device, and once you bring a piece of ferrous material or metal close to the device, it changes the magnetic field that is generated. And so one of the benefits of these switches, the inductive ones, is the fact that you do not need an actuator. So if you have an application where you're restricted and you can only really use a sensor and it's detecting a piece of metal, that's the technology to use there. These typically have a performance level D, and the outputs are what we call 2 OSSD outputs. Now, what is an OSSD output? It is a pulsed semiconductor output, and these actually can detect faults within the device. The next type of device I'll be talking about is our magnetic safety switches. So these actually have 2 reed contacts. Typically, it's normally open or normally closed. We can have 2 normally open contacts for this type of switch. But the way that these work is the actuator is consisted of a magnet, and these magnets actually cause those switches or those contacts to change state. Typically, we have a normally open and normally closed if you want to reduce manipulation, because these devices can be manipulated if you bring a magnet close to the device itself. And so having the 2 normally open and normally closed requires you to have at least 2 magnets that have the correct polarity to match. The performance level of these is similar to our electromechanical devices. So with this, the device itself does not detect short circuits, and so the performance level is indicative based on your evaluation unit, so your safety relay or safety controller. You can achieve up to PLE on these devices if you do use that correct controller. And lastly, we have our RFID safety switches. These have 2 OSSD outputs. As far as non-contacts go, this is best in class. This is what you want if you're concerned with machine operators manipulating the devices, and they also can internally detect faults. So one of the overall limitations of our non-contact switches is that they do not have a retention force. So this means that a door can be opened and closed, and so This is where we round out the rest of our switch portfolio with our safety locking devices. Within these, we have 3 different categories. We have our electromechanical, which is exactly the same as our electromechanical switches I touched on earlier. And then we have our magnetic locking devices for process protection and our devices with mechanical locking for process or personnel protection. So when we think of safety interlocks, usually there's 2 main functions: personnel protection and process protection. So personnel protection would be you're loading up a pallet. You're actually using a palletizing machine and you're packaging bags of chips into a box, stacking it onto a pallet, and then using a stretch wrapper. You want to prevent people from getting into that area, so that's where you use our interlocking switch to prevent the person from opening the door, and the force of this switch actually prevents that opening of the door. Then, say you want to use personnel protection. This is a perfect example would be you're filling soda bottles and you need to ensure that the carbonation and pressure of that machine is correct. And if someone actually opens the door, yeah, they can't get harmed by the equipment, but it spoils a whole batch of soda. And so with that, you would use a magnetic lock or a lock rated for process protection. So within our portfolio, the magnetic lock actually has 2 OSSD outputs. The RFID lock also has those dual channel outputs as well. So the important difference between these products is to just understand when to apply them. So both of them have the highest level of safety. So the MLP1 actually has the highest level of safety for process protection. However, it's not rated for personnel protection because it doesn't have that permanent locking force like our mechanical locking devices would have. With our electromechanical or with our mechanical locking devices, those can be used for personnel or process protection. So really quick, just to wrap up here, I have some of our products to actually demo. So if I open the door here, you'll notice that we have a variety of different SICK products. This is our STR1, which is our transponder switch. This has different coded actuators, so depending on your needs for your application, again, this is best in class, as good as it really gets as far as a non-contact switch. And then we have our RE11, which is our magnetic non-contact switch. Here you'll see our MLP1, which is our magnetic lock for process protection. So this actually consists of an RFID switch, that's this yellow portion here, and then a magnet. And so then once the device itself detects, yep, okay, the RFID is red, then you can lock the device and then I can no longer open the door. So with this, it doesn't have as strong of a force. Granted, I'm not that strong, so I can't pry this open, but it's 500 newtons. But if you're really looking to protect people, that's where I would turn you to our Flex Lock here. So this is actually a safety interlock that offers 180 degrees of actuation radius. So you can actually insert the actuator. It's great for doors with small radiuses. And then the actuator itself has both uniquely and universally coded. So if you are concerned with tampering or operators overcoming the safety, that's where you need to take this into account. The last product I'd like to highlight on here is our MB1, which is our mechanical bolt. It actually consists of these 2 different pieces. So we have this plate here that's really easy to mount the Flex Lock to your machine frame, and then we have a handle here that actually ensures alignment of the actuator into the device, and this is great if you're concerned with door sagging over time. So with this accessory, we also have different mounting plates that can be used for our non-contact switches as well. So if you're concerned with door sagging, take into account the MB1. It also is equipped with lockout tagout. So there's actually a little metal piece that flips up here and you can easily fit a lock in here to accomplish that as well. But without further ado, that is what I had to share with you on switches. So thanks for staying locked in with me for these few short minutes, and I'm actually going to be turning it over to Tyler.
Thank you, Sarah. My name is Tyler Gleeden. I'm a product manager covering our safety laser scanners, which you can see right here on the table. Also, safe Visionary 2, which is our new 3D safety rated camera, as well as our Safe RS3, which is our safety radar product. These are the technologies I'm going to be talking to you about today. So again, safety laser scanners, which is 2D LIDAR, Safe RS3, which is radar, and then the Safe Visionary 2, which is 3D time of flight. And I have on here on the agenda Safe Visionary 2 live demo. We're actually going to have that in the breakout. So if you are interested in seeing a live demo of this new safety rated 3D camera, please join me in the breakout and we'll go through the software and do that live demo. So talking about 2D LIDAR, what kind of technology is this? It's light detection and ranging. That's where the LIDAR comes from. This uses a time of flight principle. So the laser within the scanners here, so again we have our Microscan 3, which is this one right here, Nanoscan 3, which is the most compact safety laser scanner on the market, and then our Outdoor Scan 3, which is the world's first, and I believe still currently only outdoor rated safety laser scanner on the market. So these use the time of flight principle. There's a laser inside that hits a spinning, rotating mirror, which shoots that laser around, and we get 275-degree scan angle out of these. But with that time of flight principle, there's a light pulse that's sent out. It's very, very quickly. It's every 30 to 40 milliseconds, depending on the settings of the scanner, but it counts the amount of time it takes from that light pulse to leave the scanner, and then when it returns and when it receives that light pulse. So based on the speed of that pulse and the time that has elapsed, we get that distance measurement. So within that 275-degree scan angle, we get a contour of what the scanner sees. With the Microscan 3, we do have up to a 9-meter range. The Nanoscan 3 has a 3-meter range, and the Outdoor Scan 3 has a 4-meter range. So these are the devices where we have our longest range possible. Advantages. With the safety laser scanners, we do have up to a performance level D when it comes to the safety rating. You know, Sarah talked a little bit about different performance levels with the safety switches. I'll expand on that a little bit, what that means with the performance level. With performance level, they range from A to E, A, B, C, D, E, and it really is the amount of control reliability that's built into either your device or your full safety system. With devices, how we achieve those different performance levels up to E, being the most control reliable, is a combination of many different things, including but not limited to component selection, mean time to failure numbers in those individual components, and overall device. Diagnostic coverage is a big one. So one thing we talk about with safety devices a lot is the ability to self-diagnose errors. So that way we are always wanting to fail in a safe manner. So if there's ever any internal failure of the components or of the device, that we are failing with those safe outputs in a low state, so that we are not driving any machine motion in the event of one of those failures. So the safety laser scanners, based on the technology that they have, we do have a performance level D rating, which is pretty typical for most industrial robot cells, a lot of AGVs or automated guided vehicles, autonomous mobile robots. That is typically the performance level that's required. How do you know what performance level is required in your applications? Well, that always starts with a risk assessment. If you don't know what a risk assessment is, it would be great to join Carolyn in her breakout session. She's going to be talking about safety services right after me. And any questions you have on safety services or just risk assessments in general, any part of a safety service project, please go to Carolyn's breakout for that information. Another advantage of our 2D LIDAR or safety laser scanners, we do have a very large coverage of the area. So showed that on the last slide with the ability to go up to 9 meters of range with a 275-degree scan angle. I'm going to jump one back here so I can remember that. So that's 194 square meters of coverage that we can get with our long-range Microscan 3. Very, very impressive, can cover a large amount of area with fewer sensors. So that's going to be a huge cost savings. You also get very precise and flexible field configuration with safety laser scanners. You can, within that 9 meters and 275 degrees, configure various contours of the field, different shapes within the same field. So a lot of flexibility there in complex applications that you may need to look around different types of contours. And on the integration side, we have various integration types with our safety laser scanners, particularly the MicroScan 3 and soon to be the NanoScan 3. We've got Ethernet IP SIP safety option, Profinet ProfiSafe, EtherCAT FSOE, and then we have our own internal SIC protocol, which is based on Ethernet IP SIP safety called FE Pro. This is really advantageous when you have a safety PLC or our SIC FlexiSoft safety controller that speaks one of those safe network languages. Like Allen Bradley safety PLCs, they talk Ethernet IP SIP safety. So in the case that you have one of those, you can use the Ethernet IP version of our MicroScan 3, or soon to be NanoScan 3 Ethernet IP, in order to directly integrate with one of those safety PLCs and have no individual I/O. So it's going to save you a lot of I/O card inputs on that safety PLC, or again, your SIC FlexiSoft safety controller, and really streamline that communication. So you can configure, get diagnostics, get measurement data out from all of those devices that are on that network from just that one connection point into your network. Some disadvantages or limitations to this type of technology: we are limited to that 2D plane, so we don't have that kind of detection in multiple axes. It's just that 2D plane. And with this type of optical technology, it's not suited well for very harsh environments. With these 2D LIDAR devices, they do have what's called safe HDDM scanning technology, and that HDDM stands for high definition distance measurement. What that does for you is it gives us a lot more data points. It gives you a much more precise and consistent view of what the scanner is seeing, but more so, it's able to filter out things like dust, dirt, ambient light, IR interference from other devices like other safety laser scanners, other cameras, light curtains, things like that. So it really, in the end, it reduces false trips. But in very, very harsh environments, like extremely dusty, dirty, sometimes those things just can't be overcome. So that is one limitation of that type of technology. Target applications that are very well suited for these types of devices, again, safety LIDAR. One is horizontal area monitoring for robotics applications. In consumer goods, that could be pick and place type of applications. One big one that we see is palletizing robot cells. And again, because of that precision and the flexibility in your field configuration and the long range, we're able to cover a lot of that robot cell with very few devices. And again, that high performance level rating is suited well for industrial robot type applications. Also, horizontal area monitoring for mobile platforms. When I say mobile platforms, what does that mean? AGVs, automated guided vehicles, AGCs, automated guided carts, which is basically just a smaller AGV, and AMRs, autonomous mobile robots. Suited very well for this because, again, we have that long range, which enables a faster speed of those vehicles. We have a lot of monitoring cases that we can switch between, so you can see in the example here that one of these vehicles is turning left and it's looking to the left. You can see the different shades of red there. We can have up to 8 simultaneous protective fields, and each one of those protective fields over the safe network communication can have their own independent safe signal. So you could have those multiple protective fields trigger a slowdown, maybe 80% speed, 60% speed, 40% speed before you come to a stop. That's going to increase the productivity of these vehicles. And then lastly, vertical access protection, access monitoring for safe material flow. A lot of people look at this muting applications, human material differentiation. A lot of times we'll use safety light curtains in these applications, which are a very good option. But if you want to have more flexibility in being able to do field set switching, and like we're showing in the example here, you can just carve out and look around the material that's flowing through, but continue to monitor and safeguard that open area where a person could walk through. A safety laser scanner is a very good option here, again, because of that flexible field configuration option. Next technology, so the Safe RS3, which is the device right here. This uses radar, which stands for radio detection and ranging. Very similar to 2D LIDAR. Again, we're just sending out a signal, seeing how much time it takes to receive that signal back, and then calculating a distance based off of that. But in this case, it's electromagnetic waves instead of a light pulse in a laser. And because we're not confined to that one laser that's on a single plane, that electromagnetic wave does actually have a 3D field. And you can see on the right side of the slide there, kind of an example of what kind of field you could get out of one of these devices. These have the ability to have up to 100-degree wide field or 10-degree narrow, and that is in 10-degree increments. So there's some flexibility there, but not an extreme amount. Advantages of this, again, like the 2D LIDAR, up to performance level D rated, it does work very well in harsh conditions. That's because the radar technology is able to ignore things like dust, dirt, wood chips, flour, which might be more applicable to the consumer goods industry, things like that. It can also ignore static objects. So an object that is not moving within a particular cell, let's say robot cell, can be completely ignored, and only moving objects like a person are detected. And then also we do have a safe network variant, Profinet ProfiSafe. So again, if you have a safety PLC that speaks that language, that is an option that we have. We also have just traditional IOs as we do on the safety laser scanners. Limitations. There is lower accuracy on this type of technology than LIDAR or 3D time of flight. So we only have body detection with this type of device, whereas with the others we have hand detection, arm detection, leg detection, or body detection. And then there are limited field configuration options. Like I mentioned, you can have either a 100-degree wide field of view or down to 10 in 10-degree increments, and that's a 20-degree vertical field of view. So you can't do certain, look out 3 meters this way and 2 meters this way and have different contours like you could with 2D LIDAR. Target applications for this type of device or this type of technology: access detection in harsh environments, particularly again like flour dust. If you're experiencing that safety light curtain, safety laser scanners, those types of optical technologies aren't working, then Safe Radar, the Safe RS3 would be a good option to consider. And then lastly, for this type of technology, 3D area monitoring for restart prevention in robot cells. Again, we talk about that static object, being able to ignore static objects. So one really good application for this is that once a robot has come to a stop, you can activate these Safe RS3 devices and then just ignore everything that's not moving, but see if there's somebody inside the cell. And then once everything's cleared out, we don't see anybody moving in there, nothing moving, then we can then initiate that restart of the robot cell. Last technology, Safe Visionary 2. This is using 3D time of flight. Again, very similar. We're just counting the amount of time it takes to see an object and return something. But in this case, we're illuminating kind of the area and then just again taking that depth based on time of flight measurements. We get a grayscale image, which is intensity, and then our 3D image, which manifests itself in a 3D point cloud. And if you're interested in seeing that in more detail, come to my breakout where we'll do a live demo and I will answer any questions you have about the various technologies. Advantages of this. Safety rated 3D monitoring. So obviously we have this 3D view rather than the 2D view. Sorry, I forgot to bring this out here, Safe Visionary 2. This is the camera we're talking about. So again, you get that 3D perception, precise and accurate detection capabilities, much like the 2D LIDAR. So unlike Safe RS3, more precise and accurate, but we do get that 3D view. Like the safety laser scanner, it is more precise and accurate. And it also gives us a flexibility for field configuration. So you can use a combination of cuboids to create fields and be much more flexible, again, similar to the safety laser scanners, but in the 3D view. And then 3D point cloud data over gigabit Ethernet. So that could be used to enable certain automation type activities like robot guidance or localization and navigation in mobile applications. Limitations. This is only available in up to performance level C at the moment, so you need to ensure that in your application performance level C is acceptable if looking at using this device. And then range is maximum up to 4 meters with this device. So up to 9 meters with the safety laser scanners, up to 5 meters with the Safe RS3, and up to 4 meters with the Safe Visionary 2. Target applications, safe 3D anti-collision in mobile platforms. So this fills in gaps left by 2D LIDAR that is typically used for this type of application. So you can see here in the image we have our protective field and our warning field, and we're able to monitor that entire space. 3D protection around collaborative robots. So in an application where you have a collaborative robot and you want to be working with it, maybe handing it a workpiece, taking a workpiece from it, you always need to ensure that there's zero amount of force to anybody's head and neck area, even if this is a collaborative robot that is rated for that type of use. So this could be mounted overhead and purely just protect somebody around their head and neck area. And then lastly, 3D area monitoring for restart prevention. Again, in the case where you want to ensure that nobody's in a cell before you reset and restart a robot or whatever type of machine it may be, this is a very good option for that 3D volumetric kind of a detection, just like the Safe RS3, but again, more precision and flexibility in your field configurations. That's it for me. Again, if you want to learn anything more about these technologies or see the live demo, please join my breakout. And now I'm going to hand it over to Carolyn.
Thanks, Tyler. As Kevin mentioned, my name's Carolyn Reifstack, and I am the manager of our Consulting and Digital Solutions Safe Productivity support team. So we've talked about some great products today, some of the great products that SICK has to offer. And so what I'd like to do is just give you a very brief overview of some of the service offering that we have. So we do offer, as I can imagine, you've listened to the different product offering. I can imagine you're thinking, how can I make sure that I'm implementing these great products properly? How can we make sure that they're in compliance with the standards? So SICK actually offers a full line of services to address this. We have our consulting and design services specifically for safety, and we actually implement those over the entire machine life cycle. So starting at the OEM level, if you're in design of the products still, we can do consulting or conceptual services for you for risk assessments and safety concepts. When you get to the end user phase, we go in, we do those services on the machines themselves. So just a general overview of those services that we offer. We do offer a machine safety prioritization service. If you have a large number of products that you have no idea where to start, which ones are highest risk, we can go in and help you prioritize those. We offer risk assessment, which is a task hazard-based risk assessment. We're going in, identifying those tasks, hazards, and coming up with a risk mitigation strategy. And then moving on to the next level, the safety concept is our functional safety design of the controls. So taking what we designed in during the risk assessment and actually implementing that or tying that solution into your existing machines. So we go through that process, and then once it's approved within your organization, we will go through, prepare the electrical schematics, the configuration, and provide bill of material and the data for that solution. And then we also offer solution implementation, which is where we partner. We actually are the project manager of the job. We bring in electrical and mechanical subcontractors. We manage them, and we actually do final tie-ins, implementing that solution we've designed in. And moving forward from there, after that solution is properly tied in, we will do a verification and validation stage, basically checking to make sure that everything that was designed during the risk assessment and then fully tied in or developed in the safety concept has been installed properly and is working. We do offer this service on a global scale, so we actually have over 160 subject matter safety experts that do provide these services on for a global perspective. So not only can we implement them here in North America, but we can also, if you have locations in Europe or Asia or globally, we can actually work together. We have global project managers that can work to make sure that those solutions that have been tied in, if you want similar solutions to be implemented here in the US, for example, as well as in Germany, we can, for similar machines, we can work together to make sure that those are tied in, the solutions are shared, and we're implementing similar solutions on a global basis. And finally, we do offer a full line of safety training seminars. So we have one that's pretty comprehensive, 6 Steps to a Safe Machine, which talks about the standards and the solutions and the full process. But we also offer risk assessment training, or the specific training on the robot standards, or how they apply to collaborative robots, for example. We do offer the functional safety of machinery TUV certification, and we also offer a Sistema lab if you're trying to better understand how to do those calculations. We can actually step through that as a lab and assist you with that. So that's just a very brief overview of our safety services offering. We are going to have a breakout session. If you'd like to ask me any questions specifically, I can get into greater detail with that. So, Kevin?
Awesome. Thank you very much, Carolyn. I really do appreciate your help.
Sure.
Thank you. So for all that have joined us, hopefully this was a flood of information for you. I know it is always difficult to sip from a fire hose. So in the next 30 minutes, and again, sometimes less, we will have time for you to actually enter into a breakout room where you can meet with Sarah, you can meet with Tyler, you can meet with Carolyn, and you can talk through some of these detailed applications that you saw today. Everything from door interlocks to light curtains, all the way to LIDAR, multi-dimensional protection, as well as some of the risk assessments or safety validation plans that SICK can help put you through. So with that said, my IT team will have basically a dialog box that's going to pop up on your screen here in a second that basically will put you into a breakout room. You'll have the ability to select which room you want to enter, and once you're there, feel free to chat with the team that you just met with. It is going to be live, so feel free to raise your hand in those sessions and definitely make sure that you get your questions answered. I will be here for a few minutes, but in the event you're also like, hey, I'm all set, I've got all the information you need, you are welcome to also log out now if you don't want to go into a breakout session, and I will be emailing this link out to everybody at the conclusion of this webinar. So I really do appreciate your attendance. So my IT team is going to take it away and give you an opportunity to select the breakout room now. So thank you all.